Hello everyone. The topic for today's discussion is moment of inertia of circular plate about the axis xx, yy and zz. So let me tell you what are the axes xx. This is axis xx, this is yy, and the question in your mind will be where is axis zz. The zz axis will be perpendicular to the plane. So the perpendicular to the plane means we can say this axis is passing through this point. This axis is passing through this point perpendicular to that plane. So let me show you by this. So this axis is like this. This is perpendicular. Okay, this is perpendicular. Okay, so we know moment of inertia, the general equation is r square dA, that is I. So r denotes the perpendicular distance from the axis. So mass distribution at a distance perpendicular from the axis and its area. So considering first of all the small strip of infinitesimal thickness having, let us say, thickness dx at a distance x from the center. So the small strip have the thickness dx, so its area is given by, as it is circular strip, as we know area is what, thickness times length. So its length is nothing but the circumference and thickness will be dx. So dA is equal to 2 pi x times dx, and we know perpendicular distance will be x. So substituting these values in the equation, we get x square 2 pi x dx and moment of inertia. So tell me, it is moment of inertia about which axis? So I would like to tell you it's about zz axis. If we consider xx axis, is this a perpendicular distance will remain xx? No. For these particles it will be different and it's go on varying. So there is arise a need to consider another element. So we have considered the elemental strip which is along this axis and the distance is perpendicular, so xx, and we have considered the circular distribution of mass, and now we are doing just simplification, that is x cube, and limits of integration are of course 0 to r because it is a solid plate we are considering. For hollow plate I will make a different video. So it's r raised to 4 by 4. I am means substituted directly, so these two get cancelled, so we get pi r raised to, that is nothing but pi r raised to 4 divided by 2. In terms of diameter, we can substitute r is equal to d by 2, so I is equal to pi d raised to 4, as 2 raised to 4 is 16, so it is 32 about z axis. So how to find the moment of inertia about this xx axis and this y axis? The very simple answer to this question is lies in the theorem of perpendicular axis. So perpendicular axis theorem says the moment of inertia about the axis perpendicular to the plane is sum of the axis xx and yy. So we are doing here somewhat reverse. So izz is equal to ixx plus iyy. So in this case ixx and iyy are both are nothing but same, because the circular plate, it is the shape of plate is circular. So circular plate means it's uniform and both values will be equal. So zz is what we have already found, pi d raised to 32, and as we know both are same, so considering 2 times ixx, so it comes into denominator and we get pi raised to 64 is equal to ixx is equal to iyy. So this is the simple derivation for the equations of moment of inertia about zz axis and xx axis for circular plate. So I hope you understood. So thank you very much.